students, coming to the next topic, that is a spanning tree. A spanning tree is nothing but it is a subset of a graph. So whatever the graph you have taken, so a graph consisting of some nodes that you call it as vertices with edges which are connected each other, you call it as a graph. So this is a graph G. So the subset, a spanning tree is nothing but a subset of a graph. So in this you can construct the subsets. So this is one subset and this is another subset, like this. So this is a subset. Here we are connecting all the edges. Okay, we are visiting all the vertices. We are visiting all the vertices. Okay, means they are connected. You call it as a connected. So a spanning tree is nothing but it is a subset of a graph G which has all vertices. So here in this graph you are having 3 vertices, so which has all vertices. Okay, all vertices are covered with minimum possible number of edges. So we have to connect all the vertices with minimum possible of edges. So so we have to check the minimum edges, but all vertices should be covered. So that is a spanning tree. A spanning tree is nothing but it is a subset of a graph G which has all vertices covered with minimum possible number of edges. Hence, a spanning tree does not have cycle. So did you observe here that spanning tree is not having cycle, but a graph is having the cycle. Okay, it is having the cycle. So whereas a spanning tree does not have cycle and it cannot be disconnected. It cannot be disconnected. Okay, so whatever the graph here you taken, so this is A, B, C. So these are all connected vertices with edges. So this is a graph G. And coming to the minimum spanning tree, spanning tree, not minimum, spanning tree for this graph is A, C, B, and A, B, C, okay, or A, B, C. So these are the 3 different spanning trees that occur from the graph G. Okay, so here it is a subset of graph G. These are all the subset of graph G's which has all vertices covered with minimum possible number of edges. So this is about the spanning tree. Now let us consider weight on this spanning tree. Suppose we mention some value on this spanning tree. What did you call that? So let us see the weight of spanning tree. So weight of spanning tree, that is W of T, that is weight of T. The weight of spanning tree is the sum of weights of all edges in tree. So whatever the tree is taken, okay, so here the weight of a spanning tree can be calculated is the sum of the weight of all edges. So whatever the edges that are there, so here for this 1 plus 2, 3. So the weight of the spanning tree here is 3. Means is the sum of weight of all edges in the tree. And coming to the next point, minimum spanning tree. So what is this minimum spanning tree? Minimum spanning tree is represented as MST. A minimum spanning tree is a spanning tree with the smallest possible weight. So we have to select the smallest edges, the smallest possible weight in the tree. So which edges is having the smallest weight, and that should be connected all the vertices. That is a condition for the minimum spanning tree. So we have to select the smallest path. Okay, so let me explain with example. So let me take the weighted graph. So I'm taking the weighted graph, not a spanning tree. So a graph. So these are the nodes. So all vertices are connected. So this is a graph, and the weighted graph means you have to include the weight on each edge. 1, 2, 3, 4, 5, 6. So here from this node to this vertex is connected with edge. This weight on this edge is 1. So this is a weighted graph. Now let us see minimum spanning tree from weighted graph. So here in this weighted graph we have to select the minimum spanning tree. So what is the condition of minimum spanning tree? A spanning tree with smallest possible of weights we have to consider. So first, what is the smallest possible weight? These two nodes. Let me first write the vertices, because we have to visit all the vertices. That is the first condition, and then we have to select the smallest possible path. So 1 is the smallest, 1, and next 2, and coming to here, and this is 3. So all vertices are connected now. So this is, then the minimum spanning tree weight is, here weight is 1 plus 2 plus 3, that is 6. So this weight is 6. So this is how you have to calculate the minimum spanning tree. So the only condition is we have to select the smallest possible weights. And one more thing, all the nodes, that is all the vertices should be visited. Okay, and that should be connected. One node is connected with another node. So there is no discontinuity here. No disconnected nodes are accepted here. Okay, all the vertices has to be visited. And coming to some examples, in the live example, suppose if the minimum spanning tree would be in the design of networks. So the first thing is minimum spanning tree can be used in design of networks. In how way this MST can be used in design of networks? So in network, MST used to determine the least cost path with no cycles in networks. So it's mainly based on least cost. Least cost path has to be selected in the network. Okay, so thereby connecting everyone at a minimum cost. And coming to the second example, MST would be used in finding airline routes. So in airline routes also we will use the MST technology. So there the vertices of a graph represents the cities. So in the airline routes, vertices represents cities and edges represents route between cities. Route between cities. So based on the this distance covered by this airline route, so this MST can be applied here to optimize the airline routes by finding the least cost path with no cycles. So the one thing here you have to remember that the MST can be implemented with no cycles. With no cycles. Okay. So now coming to next, MST, that is the minimum spanning tree, can be constructed using any of the two algorithms, the most important algorithms. MST can be constructed. It can be constructed using number 1, Kruskal's algorithm. Kruskal's algorithm. Or you can implement MST by using Prim's algorithm. So these are the two algorithms that are used to construct the minimum spanning tree. So the main thing here, the Kruskal's algorithm mainly uses edges. it is constructed based on using edges, and whereas MST uses vertex. So Prim's algorithm uses vertices, whereas Kruskal's algorithm uses edges for connection in determining the minimum spanning tree. So in the next videos, we'll discuss about what is the Kruskal's algorithm and what is the Prim's algorithm with an example. Thank you.